The God Theory, Universes, Zero-Point Fields, and What's Behind It All, by Bernard Haisch. Narrated by Norman Dietz. Copyright 2006 by Bernard Haisch. This unabridged audiobook is published by arrangement with Red Wheel Wiser Books, and was produced in the year 2011 by Tantor Media, Incorporated, which holds the copyright thereto. Preface. A remarkable discovery has gradually emerged in astrophysics over the past 2 decades, and is now essentially undisputed, that certain key physical constants have just the right values to make life possible. In principle, these constants could have taken on values wildly different from what they actually are, but instead they are, in some cases, within a few % of the just right values permitting us to exist in this universe. As Sir Martin Rees, the British Astronomer Royal, and one of the world's foremost cosmologists, writes in his widely read Just 6 Numbers, our emergence and survival depend on very special tuning of the cosmos, a cosmos that may be vaster than the universe that we can actually see. Science today is based on the premises of materialism, reductionism, and randomness. Materialism is the belief that reality consists solely of matter and energy, the things that can be measured in the laboratory or observed by a telescope. Everything else is illusion or imagination. Reductionism is the belief that complex things can be explained by examining the constituent pieces, such as the illusion of consciousness arising from elementary chemical processes in the brain. Randomness is the conviction that natural processes follow the laws of chance within their allowed range of behavior. Given those beliefs, there's one and only one way to explain the fine-tuning of the universe. An infinite number of universes must exist, each with unique properties, each randomly different from the other, with ours only seemingly special, because in a universe with different properties we would never have originated. Our existence is only possible in this particular universe, hence the tuning is an illusion. This view suffers from 3 problems. First of all, quantum fluctuations are a key ingredient of inflation theories that attempt to address how our universe and myriad others came into being. The problem is that quantum fluctuations presuppose the existence of quantum laws. If there truly were no quantum laws or any other laws whatsoever, nothing could happen. No laws, no action. The origin of universes as a result of quantum laws, inflation fields, or other arcane properties of string theory depends upon the pre-existence of those laws or fields. And so, even the skeptical scientist cannot avoid taking that on faith. The second problem is that none of the other universes can ever be observed, not even in principle, since trying to measure across universes with different fundamental laws would be like using a microphone to observe the moon or using a telescope to record a rock band. So yet a second article of faith is required of the modern scientist: the existence of an infinite number of unseen universes. The final problem is more personal. If we're nothing but physical beings originating by chance in a random universe, then there really can be no ultimate purpose in our lives. This is not only bad news for us individually, it undermines the ethical and moral underpinnings of society and civilization. I propose a theory in this book that does provide a purpose for our lives, while at the same time being completely consistent with everything we've discovered about the universe and about life on Earth, in particular the Big Bang, a 4.6 billion-year-old Earth, and, of course, evolution. The single difference between the theory I propose and the ideas current in modern astrophysics is that I assume that an infinite conscious intelligence pre-exists. You can't get away from the pre-existence of something, and whether that's an ensemble of physical laws generating infinite random universes or an infinite conscious intelligence is something present-day science can't resolve, and indeed one view is not more rational than the other. One might argue that one view is supported by evidence and the other is not. I would agree 100%. The evidence for the existence of an infinite conscious intelligence is abundant in the accounts of the mystics and meditative, prayerful, and sometimes spontaneous exceptional experiences of human beings throughout history. The evidence for random universes is precisely zero. Most scientists will reject the former type of evidence as merely subjective, but that simply reduces the contest of views to a draw, zero on both sides. What I propose is an infinite conscious intelligence, so let's call it God, who has infinite potential, whose ideas become the laws of physics of our universe and others, and whose purpose in so doing is the transformation of potential into experience. The difference between being able to do something and actually doing it is vast. Making it happen, experiencing what it feels like, savoring the sensations are the tremendous difference between theory and practice. Playing the game is far more satisfying than reading the rules. Astrophysicist Sir James Jeans wrote in the 1930s, "The universe begins to look more like a great thought than like a great machine." So, too, I am proposing in the God theory that ultimately it's consciousness that's the origin of matter, energy, and the laws of nature in this universe and all others that may exist. And the purpose is for God to experience his potential. God's ideas and abilities become God's experience in the life of every sentient being. What greater purpose could there be for each of us humans than that of creating God's experience? God experiences the richness of his potential through us because we're the incarnations of him in the physical realm. That's what it's all about. Introduction. Much of today's religious dogma concerning God and the nature and destiny of mankind is flawed and irrational. It fails to resolve basic paradoxes, like why bad things happen to good people, and why some are born into privilege and some into starvation and misery. Moreover, the conflicting claims of the world's religions contribute directly to the violence and hatred that afflicts much of the planet. On the other hand, rejecting anything pejoratively called supernatural in the name of science is equally flawed and irrational. After 3 decades as a professional scientist and a lifetime as a seeker, I've arrived at a personal worldview that offers a satisfying and hopeful explanation of reality, a worldview that's not only possible, rational, and compatible with modern science, but compelling and capable of resolving some of the most intransigent moral issues facing us today. It embodies a way out of our global dilemma, and so I offer it for your consideration. Let me make it clear that I don't claim to speak directly to God. I'm too conditioned as a scientist for that. In fact, if God ever calls, my line will probably be busy, but he might try my email. Precisely because I'm a professional scientist, this book represents a gamble for me. I'm gambling that there's a significant audience interested in a kind of rational spirituality that can nudge the world in a more tolerant and uplifting direction. I'm gambling that somewhere between the hardcore reductionists who explain all things as the sum of their parts and greet every suggestion of spirituality with a sneer, and the unquestioning faithful who receive their beliefs full-blown from prophets and preachers, there's a group of philosophical centrists, well-intentioned, open-minded, skeptical, but free spirits eager to investigate their own nature. I'm gambling that these inquiring spirits, among whom I count myself, will join me as I explore the handiwork of an extremely ingenious God who, nevertheless, can only experience material reality by living in and through us and all beings everywhere. To you I propose a God whose purposeful ideas somehow became the laws of nature underlying our universe. I propose a God whose infinite diversity of ideas was capable of initiating the Big Bang some 14 billion years ago, and also of supporting the other multiverses that astrophysical inflation theories cobbled up over the years. The difference between my proposed worldview and the prevailing reductionism of modern science is that its theories rest squarely on enigmatically pre-existing and randomly distributed laws of nature, mindlessly giving rise to universes that are utterly devoid of purpose. Mine rests on an acceptance of an infinite intelligence as the source of our universe and all the other universes that modern astrophysical inflation theory postulates. I am gambling that a closer examination of spiritual realities will also appear to skeptical reductionists, plagued by the nagging, and perhaps secretly welcome, suspicion that there may, after all, be more to life than the equations of physics. What I propose may also appeal to those who, although open to the idea of a benevolent deity, are put off by the dogmatism of organized religion. I'm also betting that scientific discoveries in this new millennium will substantiate that the rich inner world of consciousness we all share is more than just a neurophysiological epiphenomenon. I'm betting that before too long we'll understand how consciousness, at a fundamental level, creates matter, not vice versa. This view has roots deep in ancient mystical traditions, but is currently heretical to modern science. My wager is this: as science integrates the in-depth knowledge of the physical world accumulated over the past 3 centuries, it will be channeled into a new and exciting line of inquiry that acknowledges the expanded reality of consciousness as a creative force in the universe and the spiritual creative power embodied in our own minds. This book summarizes the thoughts of an inquisitive but open-minded scientist. What I present here is a theory that looks promising, not scientific proof. It should not be surprising, however, if some of what I propose coincides with theories propounded by others who claim a more intimate relationship with the Almighty. After all, if I'm on the right track, and if they are, it'd be worrisome if we weren't ultimately in agreement. All I ask is that you seriously consider the logic of my theory, especially if it challenges you to question what you were taught in Sunday school, in catechism, or, dare I say, in physics class. I offer this book not as a theological treatise, but as a short, readable exposition of a worldview that can bring sense and purpose into individual lives, and tolerance and peace to a planet whose future is in serious jeopardy, in large part because of the irrational dogmatism of both religion and science. If I'm correct, we are literally all one being, God, in many individual forms. Why then would we continue to harm one another? Chapter 1. Personal Journey. The seeds that gave meaning to my life were planted at an early age. I was born in Stuttgart, Germany, to German parents who moved to the United States when I was 3 years old. They came to Indiana because my mother's sister and her husband had moved there after the war. Post-war Germany, even in the 1950s, was a pretty bleak place, and America was the golden land of opportunity. My aunt sent glowing and exaggerated letters back to my mother about a bakery that was available on the south side of Indianapolis. It was cheap, and they could all go into business together. When my parents arrived with a few trunks, a few dollars, and one kid, me, the bakery opportunity proved to be only half-baked. I'm glad. Otherwise, I might have been a baker, and this might have been a cookbook. My early childhood was shaped by a scrupulously religious Catholic mother, and by the good Sisters of Providence at St. Catherine of Siena Parochial School in Indianapolis, who started each school day by herding us all to Mass, on the assumption that this was the best prelude to reading, writing, arithmetic, and, of course, catechism. In fact, my mother wanted me to become a priest, and I'm sure she sent a lot of prayers heavenward to that effect. Now, being a priest would have been more exciting than being a baker, but as a child I always loved science. I can't remember a time when I didn't want to be a scientist, and specifically an astronomer. There are some things that you just know, especially as a child, when your world isn't yet filled with the ambiguities and doubts that grow and haunt you later in life. As a child of the Sputnik generation, I loved to watch the space cadet programs on television. Years later, at the Museum of Television and Radio in New York City, I tracked down an episode of Buzz Corbin and Cadet Happy that I think may have helped launch my space career. It was unbelievably silly. One back-and-forth joystick seemed to be all the control Buzz needed to fly around the galaxy in his interplanetary rocket. Life was remarkably simpler for them than it was to be for Captain Kirk, Commander Scotty, and their warp engines only a decade later. By the time I entered the first grade, I already had a curious certainty that I'd grow up to be an astronomer. I vividly imagined exploring the surfaces of other worlds through a huge telescope, like the 200-inch reflector on Mount Palomar. Although what I imagined far exceeded what even such a telescope could actually deliver, the dream was real. I was comforted by knowing that a grand destiny awaited me in astronomy, that there were discoveries just waiting for me to make. Because of my mother's devout religion and my own fascination with space, I developed a strong conviction at a very early age that I would become a priest astronomer like Father Giuseppe Piazzi, who discovered the first asteroid, or Father Angelo Secchi, who in the 1800s was the first to classify stars according to their spectra. I learned as I grew older that these two vocations are not, in fact, incompatible. There are Jesuits who are professional astronomers in good standing. In the 18th and 19th centuries, the Catholic Church operated several observatories in Rome, and the official Vatican Observatory, founded in 1891, maintains a modern facility atop Mount Graham in Arizona, adjacent to the prominent Kitt Peak National Observatory, in partnership with the University of Arizona. I relished the idea of being involved in something really grandiose, something having to do with God and space. How much bigger can a dream be, after all? Not even the sky was my limit. I pursued the dream of the astronomer priest for a few years beyond grade school. In high school, I attended the Latin School of Indianapolis, dedicated to preparing young boys for the seminary. I received a first-rate classical education, courtesy of the archdiocese, that would have cost a fortune at a private East Coast prep school. Along with the usual English, history, algebra, biology, and physics, I got a hefty dose of Latin, rhetoric, and Gregorian chant. After high school, I moved on to a college seminary run by the Benedictine monks of the St. Meinrad Arch Abbey in the rolling hills of southern Indiana. There the dark-robed monks lent an almost medieval atmosphere to my world, especially on brooding gray winter days when we all assembled for Mass in our cassocks and Roman collars and sang the ancient chants with our Kyriales. Requiem aeternam dones Domini. It felt like the Middle Ages. I attended the seminary for just 1 year, however. From the moment I arrived, the possibilities of a different kind of future, especially one involving girls, drew me away from the enclosed worldview of the monastery. Surely, I thought, computation had an edge over prayer in the technological world of the late 20th century. I abandoned the priestly half of my dream when I was 18. However, the other half of my dream I followed all the way, becoming a professional astronomer. I've had a successful career working in the United States and in Europe, doing research, frequently competing for and being awarded observing time on orbiting NASA telescopes, writing scores of scientific papers, chairing international conferences, serving as a scientific editor for a prestigious journal in astrophysics, refereeing proposals for the National Science Foundation, giving lectures, and the like. From Arch Abbey to Astrophysics. My transition from Arch Abbey to astrophysics took place the following summer. It was, by any measure, a memorable time. Robert Kennedy and Martin Luther King, Jr. had been assassinated. Vietnam and a tragic, divisive incoming president were polarizing the nation. Yet amid all this, we were going to the moon. The Apollo program had achieved lunar orbit, and on July 20th, 1969, the moon landing took place. Human beings had reached another world. A turning point in civilization had been reached, or so it seemed. Providing you could look away from the raging chaos on the surface of our planet, the outbound direction into space and other worlds seemed full of promise. It had taken less than 12 years to go from primitive Sputnik and Buzz Corbin's one joystick does-it-all rocket to landing astronauts on the moon. Surely another 12 years would be sufficient to take astronauts onward to Mars. That's how things looked to me as I went from the spiritual world of the St. Meinrad Seminary and Arch Abbey to the scientific world of an astrophysics major at Indiana University. On the Indiana highway map, St. Meinrad lies a mere 100 miles from Indiana University, but it felt more like 100 light years. In my sophomore year at Indiana, I learned how to use a telescope and take photographic plates at the campus's Kirkwood Observatory. I became deeply involved with physics and its applications to astronomy in general. I began to study in depth the nature of stars, galaxies, planetary nebulae, the interstellar medium, and the like. Before long, monasteries and the calling to a priesthood were remote and irrelevant memories. When I graduated from Indiana University, I went straight into a graduate program in astronomy and astrophysics at the University of Wisconsin in Madison. Wisconsin was one of the top 10 schools in astronomy and astrophysics in the country, and had just launched a major NASA mission, the Orbiting Astronomical Observatory. They also had excellent beer up there. Wisconsin had a fast-track astronomy program that enabled me to obtain my Ph.D. by the time I was 25. My doctoral thesis dealt with radiative transfer, a mathematically oriented description of how light and other electromagnetic radiation passes from inside a star and out into space. This kind of inquiry requires huge supercomputers, like those at Los Alamos or Livermore, where much of the work is very closely related to nuclear weapons. Since that didn't interest me, I grew away from the subject, which I'd begun to see as just too technical and too complex, involving too much of what scientists call number crunching. Launching a career. By the time I graduated, the job market was nearly saturated and unemployment was a looming threat. I was lucky enough, however, to be offered a postdoctoral fellowship doing research for Jeff Linsky at the prominent Joint Institute for Laboratory Astrophysics at the University of Colorado in Boulder, a world center for research in astrophysics. Once again I found myself immersed in a belief system of sorts, but this time the decidedly secular one of academia. Here at the foot of the Rocky Mountains, with the soaring Flatirons looking like a Hollywood backdrop, was one of the top research institutes. Scientists from all over the planet came here to spend a summer or a year, and I'd been welcomed into this secular sanctum sanctorum and given a chance to start proving my worth as a modern researcher. Was this not heaven on earth? Linsky's work involved obtaining data from NASA satellites, especially those dealing with the ultraviolet and X-ray parts of the spectrum. I, along with his other postdoctoral fellows, analyzed and tried to interpret that data. Our job was to generate a flurry of research papers that coaxed every possible bit of astrophysical insight from the precious satellite observations. This established reputations, advanced careers, and kept the grant money flowing. It was Linsky who stirred my passion for a class of stars known as cool stars. By stellar standards, our sun is a cool star. At about this time, I began reading about Buddhism. I remember thinking to myself, perhaps because I was an astrophysicist with some bona fides as a seminarian, that there was some connection to be made, some insight on the deepest nature of things to be discovered that only someone with my background could uncover. But that interest was soon tabled as my personal and professional lives became more complex. I was offered a research position at the University of Utrecht in the Netherlands, which I accepted. The Dutch were very active in astronomy, doing ultraviolet spectroscopy from a balloon-borne spectrograph launched, oddly enough, from Palestine, Texas. Of course, anyone who knows the dreary Dutch climate will understand why Dutch astronomers would spend their time under Texas skies. The Dutch get around. After a year in the Netherlands, I returned to the United States and rejoined Linsky in Colorado. Not long after, I was offered a job with the Lockheed Palo Alto Research Laboratory. My work at Lockheed allowed me to do a remarkable amount of astrophysics, thanks in part to a highly classified program that's now well known, the SPY satellite program. They wanted me to provide them with astrophysical information in order to very accurately calibrate their telescope using star positions. I had nothing against surveillance. Spying on each other is a reasonable way to keep peace. Essentially, they wanted me to develop a very precise catalog of star brightnesses. So I created an elaborate computer program for them that was probably 10 times more accurate than anything ever done for a classified program, though I can't be totally sure of that, since all such stuff was, after all, secret. Lockheed seemed to have lots of money back then, this program in particular, and didn't really care what I did so long as the star catalog was a success. And it was. So I spent a lot of my time doing astrophysics beyond what they really needed, and no one seemed to mind. I even managed to initiate new stellar research by winning some NASA grants. Perhaps as a result, within a couple of years I was invited to join a research group at Lockheed that actually made its living from NASA projects instead of classified programs. It was called the Space Sciences Laboratory at the time, and later split and morphed into the Solar and Astrophysics Laboratory. They were, and still are, the world's leading group in solar physics. I studied flares on stars, which had become a hot topic in stellar astronomy because you could see them with the new ultraviolet and X-ray telescopes launched by NASA. But I also became involved in the analysis of data from the solar max.
Sample complete. Ready to continue?